Hey everyone. Okay, so this is now lesson 5 of our rational expressions and equations unit for 30-2, and we are going to tackle adding and subtracting. Now, for those of you who are using the book to kind of follow along, this is a larger lesson. It's actually going to be over 2 days. This video will get you set up for those 2 days, and then you just have lots of work to do because this one's a little harder than multiplying and dividing. Okay, so we just want to make sure you have enough of a chance to really feel solid about what's happening. And the way you feel solid about what's happening is you practice it. Okay, so let's review. We're going to kind of shape this lesson the same way we did with lesson 4 on multiplying and dividing. And so the first thing we want to talk about is, okay, let's just get our brains back into fraction mode. When we were taught fractions way back when, how did we add or subtract fractions? And one of the key differences in adding or subtracting fractions compared to multiplying and dividing, with adding and subtracting, you need something called a common denominator. That bottom number has to be the same. In order to add or subtract, the pieces have to be the same size, essentially. So 1/4 is not the same size as 1/8, okay? And so I can't add those together without first kind of figuring out, okay, what if I called them both the same sort of size of a piece? And then I could add those pieces together. That's essentially what we're doing when we get a common denominator. So very quickly, let's just read through the directions here. I'll hide my head so you can see them. Let's see if we remember how to add or subtract fractions without our calculator. Simplify the following expressions. So when I look at 2/3 plus 5/4, I'm going to be thinking in my head here, okay, I need a common denominator. So I need to have the same number on the bottom. Um, Often we can get that by multiplying these guys together, okay? But sometimes we don't have to. Sometimes a smaller number exists, okay? So I'm going to say this one statement, and it might not make total sense right now, but it will as we keep going. You kind of need one of every factor that you see, okay? So here, I do need both the 3 and the 4. So I'm going to multiply these guys together, which means I want a 12 on the bottom. Okay, now I need to ask myself, okay, how did I go from the 3 to the 12? Well, I multiplied by 4. So whatever I do to the bottom, I have to do to the top, and that will become an 8. Okay, then I'm just going to switch colors so I don't get too messy here. How do I go from the 4 to the 12? Well, I multiplied by 3. So whatever you do to the bottom, you have to do to the top, so that will become a 15. And then I'm ready to actually do the addition. Now that my pieces are the same, they're all in 12ths, okay? I can just go 8 plus 15, and that'll be 23/12, okay? Okay, so I'm just going to erase this and let the computer do its work, but I said the same thing. I'm pretty sure. I'm pretty sure we're going to agree with each other. Now, going back to that statement, I need one of everything. Let's see how that would look with 4/7 minus 3/8. And so what I'm going to do here is just kind of show it to you in a different form. I'm going to say, okay, this guy has a 7, this guy has an 8. That means my common denominator needs to be a 7 and an 8 multiplied together. Okay, so the first guy needs an 8, so I'm going to put an 8 on the bottom and on the top. The second guy needs a 7, so I'm going to put a 7 on the bottom and on the top. Okay, it's essentially the exact same thing I said above in that first example. It's just a little bit of a different way of looking at it. But what I want you to see with this sort of method is this is how we're going to kind of go forward from here, because the 7 won't be a 7. It might be like an x plus 2, and the 8 might be like an x minus 3. And so our common denominator is going to be one of each of them. Okay. So your common denominator ends up being one of every factor that you see. Okay. Represented on the bottom, of course. Okay. So that now is going to give me a 32 on the top, and it's going to give me a 21 here for this top. I already have a common denominator of 56, so I'll just go 32 minus the 21. as my numerator and then figure out what that is. So 32 minus 21 is 11, and then I'm good to go. Okay? All right, so that's what we're going to start practicing in this video together. It's just going to look a little messier because we're going to have polynomials going on instead of just straight up numbers, but it's totally doable, and you guys are going to rock at it. Don't stress. Okay, so I'm going to hide my head again for one quick sec. So adding and subtracting fractions is slightly more difficult than multiplying and dividing because first you have to get that common denominator, okay? First, you have to get that common denominator. Now, if we can determine the lowest common denominator, that's even better, okay? So when can we divide? Again, I know I've had this conversation with you already. This is a little bit of a don't be a kitten killer sort of a conversation, but it's really, really important that we keep having this conversation because it's such a common mistake that kids make, especially when you're writing a test and you get yourself a little stressed out and you forget when you can divide something out and when you can't divide something out, okay? So for the 2 plus 3 over 2, can we divide the 2's right now? The answer is a resounding no. Incredibly important. Only factors of the numerator and the denominator that are the same may be divided. Sorry, that shouldn't say my, that should say may there. I can fix that for you if I could find my ink. There it is. Okay. May be divided. Okay. It's kind of like the Amazing Race. You may be eliminated. No, it's not like that at all. So this guy here, you cannot divide the 2 and 2 because the 2 is attached to the plus 3. Okay. All right, so let's actually just go through examples of when I can and can't do that, just so that you can see them, okay? So all of these guys here, I'm okay to divide. I'm happy. I'm kind of looking a little smug, actually. But something like this, 6 over 2, I could look at that as 2 times 3 over 2. These 2's are totally okay to be divided because what's happening on top is a multiplication statement. Oh, sorry. Okay, because what's happening on the top is multiplication, now I can say 2 divided by 2. They're separate. They're okay to go. Okay. Next example, something like this. Okay. X plus 1 and x plus 1. Those are factors shared on both the top and the bottom. I can totally divide those out and say I'm left with x. Okay. How about this guy here? The x squared minus 9 factor is available to me both on the top and the bottom. There's no addition or subtraction sign here, so these guys are being multiplied together. So as long as it's multiplication, I can divide these guys out, okay? So essentially, now just to give that to you kind of as a picture, if I'm set up as multiplication of separate factors, then if one of these factors are the same, I could divide them, okay? Okay, so that's very, very different from here. Now we have a sad, exasperated face. This is a don't do this one face, okay? You got to pay attention to my faces. 2 minus 1 over 4. You cannot do anything with that 2 and the 4. Okay, don't look at this and say, oh, I can reduce that fraction. No, you can't because the 2 is connected to the minus 1. Okay. Okay, I know that looks silly because it's just numbers, but we're going to go through some with factors as well here. Okay, so x minus 1 plus 4 over 4. Don't let those eyes of yours dart right to here and say, oh, I can divide those out. What you need to see is that plus sign. As soon as you see that plus sign, you're connected to that x minus 1. So you can't divide something out unless it's fully multiplication, not addition or subtraction, okay? So another example of that might look like this, okay? So don't look at those x plus 2's and say, oh, yay, I can divide the x plus 2's out. No, you can't. And the reason, again, is because of that subtraction sign. That subtraction sign connects this whole thing together, which means you can't divide out the x plus 2's because the x plus 2's aren't, or at least on the top, the x plus 2 is not a factor. Maybe if I say it that way, that might make more sense, okay? Okay, and so essentially, if you have like symbolically something that looks like this, you want to be careful that you don't look at these guys and say you can divide them out because of that plus sign. Okay, as soon as you have that plus sign there, those two items are now intricately connected together. So you could only divide them out if you see the same two items being added together as a factor on the bottom. Okay, hopefully that's feeling okay. Hopefully I'm not stressing you out with this. If I am, rewind me 30 seconds. Try me again, okay? Because I really, really want you guys to have a good understanding of what's going down here. Okay, so now we're going to try all of this, but we're going to do it with rational expressions, okay? So the question says, add or subtract the following and state all restrictions. So we're going to kind of go through the same sort of order. Okay, remember our order. I'm going to write it down for you here just in case you don't. Number one, do you remember number one? It was to factor. Number two, state your restrictions or your NPVs, whatever your teacher likes to call them. They mean the same thing. Okay. Number three, do the math. Okay. So whether that math now is you could simplify or you got to get right to a common denominator or whatever you're doing, do that math. But number one always needs to be factor. Number two always needs to be state the restrictions. Okay. So in this example, number one, the factoring portion, well, there's nothing to factor. So now I can go right into my restrictions and I can see I've got an X on the bottom of each of these. So X can't be 0. Okay. Now I need a common denominator. For this one, actually, 8x squared is my common denominator. The reason I say that, this is analogous to say, I don't know, let's say I had a 4 and I had a 12. Could I get a common denominator by multiplying these together? Sure, I can. Do I need to make my life that difficult, though, and deal with 48? No, because I can make a 4 turn into a 12 just by multiplying it by 3, right? So then 12 would become my common denominator. Now, we're not talking about 4 and 12, but it's the same sort of conversation over here. I can make a 4x turn into an 8x squared just by multiplying it by 2x. So because of that, I'm going to just throw a 2x on the bottom and on the top of them. And that would look like this. So now I have a common denominator of 8x squared for both of these guys. So I can write this as one fraction with an 8x squared on the bottom. And on the top, I'm going to have 3 plus 2x. Now, I then switch that order just because with polynomials, we like to have the x term and then the number, right? Remember, polynomials are always written from highest degree to lowest degree, okay? Awesome. All right, in this next question, we're looking at 2 over x minus 3 over x squared. So again, we're going to follow our steps. Step one, factor. Nothing to factor here. Nothing to see here. Okay, number two, we need to talk about NPVs, and we know that x can't equal 0 for this guy because I have an x or an x squared on the bottom. Both of those would give me that x can't equal 0. Okay, now I need a common denominator. And again, this is similar to the first example I gave you. My common denominator is not these guys multiplied together because I can actually take the first fraction, I can take that x and turn it into an x squared just by multiplying it by x. So my common denominator is actually going to be x squared. Okay, so that means I need an x on the top and on the bottom here because whatever I do to the bottom, I have to do to the top, right? Those all still stay the same sort of mantras. Mathematical laws might be a better way to say that. Okay, so this is going to give me 2x minus 3 on the top over x squared. And then that's it. That's my answer. Okay, that one was easy peasy. Okay, 2 over x minus 2 minus 3 over x. Now, step one, factor, nothing to do here yet, okay? But in a common denominator standpoint, here's an example where I can't turn an x into an x minus 2, right? I can only get common denominators through multiplying or dividing things. Don't look at this and say, oh, I just have to subtract 2 from both sides. You can't do that. That's not a thing, okay? So I need one of each factor, okay? So I need an x and I need an x minus 2. Now, before I get going there, let's talk about non-permissible values. X can't equal 0 and x can't equal 2. So we want to state that. And now I need that common denominator. So this guy's going to need an x on the bottom with an x on the top. this guy's going to need an x minus 2 on the bottom with an x minus 2 on the top. Okay, see how I did that? I've color coded it there so that you can kind of see this guy needed the x so that my common denominator was x times x minus 2. This guy also needs that x. This guy needs the x minus 2 in order to have the common denominator, so I do the same thing to the top. Now, on the bottom, I've got that x times x minus 2. I can just leave that in factored form. I don't need to multiply that, but I do need to clean up the top. So if I'm cleaning up the top, this is going to be 2x. I need to kind of watch that negative or the subtraction sign there. Treat this like a -3. And so the -3 applies to the x and the -3 applies to the -2. So that's going to give me -3x and then plus 6 because of that negative. Okay, so that's going to give me 2x minus 3x plus 6. And then I'll clean that up. That'll be -x plus 6, again, over my common denominator. Okay? Fantastico! We can add and subtract, no problemo. Okay, let's try 3x over 2x plus 1 minus 4 over x minus 3. Again, same steps. I don't want you to think I'm boring, but I do want to get it in your head. And when you're writing your test, I want you to hear me whispering in your ear. Step 1, factor. Step 2, state NPVs. Step 3, do the math. So step 1, factor, nothing to do here. Step 2, state my NPVs. This is going to be -0.5. This is going to be 3. Now, again, I'm going through that quickly, friends, because we've already had a lesson on how to find your NPVs. If you're struggling with that, don't stress, but go back and watch that lesson again to make sure you're with me, okay? And as always, like if you're like, how did he do that? Don't forget, you can just take the bottom of the fraction, set it not equal to 0, and then just you're working on isolating x, right? Okay, but I won't take the time to do that right now because we have covered that in another video. Okay, so now I need to get my common denominator. Again, my common denominator is going to be one of each item that I see. So I've got a 2x plus 1 and an x minus 3. This first fraction doesn't have the x minus 3, so I'm going to throw that on the bottom and throw it on the top. The second fraction doesn't have the x plus or 2x plus 1, so I'm going to throw that on the bottom and throw that on the top. And so that would look like this. Okay. Now I'm going to have to clean things up. So again, I'm just distributing this 3x times x, 3x times -3. And again, over yonder for the second fraction, treat that as a -4. So that's -4 times 2x and -4 times the 1. Okay, so that's going to give me 3x squared minus 9x, and then -4 times 2x is -8x. So remember, if your answer is negative, you're subtracting it, right? And if your answer is positive, you're adding it. And then I've got -4 times 1, which is the -4. Okay, so now I can clean that up a little bit further. -9x and -8x together would give me -17x. Okay. There's always a wonderful conversation here around, can I factor this? I'd be looking for two numbers that multiply together to give me -12 and add together to give me -17. They don't exist, so I am done right here. This is a beautiful question. Okay, so, oh, let me take that ink off for you. Apologize about that. Okay, so now we're taking a look at this. Now, remember, step 1, factor. We actually have something to factor here. Yay! I've got a difference of squares on the bottom left-hand corner of this guy. X squared minus 16 will factor into x plus 4, x minus 4. Okay, so we're going to do that first. Then we're going to state our NPVs. I know that x can't be plus or minus 4. Then we need a common denominator. Now, here's what I want you to see. They both already have an x minus 4, so that part is already common. I don't need to multiply all this together, okay? What I do need is the second fraction doesn't have an x plus 4. So I'm going to throw an x plus 4 on the bottom of the second fraction and on the top in order to make sure I'm not changing things. Then that 4 will get distributed, so that'll be 4x plus 16. 32 plus 4x plus 16 on the top and a common denominator of x plus 4, x minus 4. And then just to clean that up, 32 plus 16 is 48. So I'll end up with 4x plus 48. Okay, now I can factor that 4 out. That is factorable. I might as well leave things in a nice factored form here. So factor out the 4 and I'll be left with x plus 12 over x plus 4, x minus 4. Okay, we totally have this. This is awesome. Okay, let's try this guy, x squared plus 9 over 9 minus x squared. Subtract x over 3 minus x. So top left, there's nothing to factor there. Don't look at that and say, oh, yeah, I have a difference of squares. Remember, difference is subtraction, and that's actually an addition of squares, okay? But on the bottom, I do like the bottom left, 9 minus x squared. That is the difference of squares. So I can factor that into 3 plus x and 3 minus x. Now I have everything in factored form. I'm ready to talk about my non-permissible values, which would be plus or minus 3. And then I need a common denominator. Well, I already have the 3 minus x. So the second fraction needs the 3 plus x. So I'll throw that in on the bottom and on the top. And now I'm ready to just clean things up. So I have my common denominator, 3 plus x, 3 minus x. I'm going to have x squared plus 9. And then I'm going to have minus x times 3. So that's going to be a negative 3x squared. And then minus 3x. That was my bad. Sorry. Minus 3x. You all with me? Okay. And then what? Minus x squared. Okay. So, oh, sorry. I got to get my mouse back here. Okay. So x squared plus 9 minus 3x minus x squared. So now x squared minus x squared is 0. So I'm left with 9 minus 3x. Okay, 9 minus 3x, I can factor that. I can take out a 3. So that'll leave me with 3 times 3 minus x. Oh, yay, look! My 3 minus x's will divide out, and actually then I'll be left with 3 over x plus 3. That's kind of fun. I feel like that deserves a little. Yay, this was fun. Okay, good. See, friends, that's not bad, okay? It's a little bit more work than adding or multiplying and dividing, okay? But it's all doable work. You can do this, okay? So let's summarize what we've done. What have you done? Okay, well, this is what we've done. First step, always. What was my step 1? Oh, did you see my head shook there because I banged the table and it shook the camera? Okay, sorry, little sidetrack there. Factor completely, always. I'm just gonna hide my head for 1 sec. Binomials and trinomials. Any binomial and trinomial you got there, make sure you factor. State all the non-permissible values or the restrictions, if your teacher calls them that, they are the same thing. Simplify if possible. Hey, look, friends, that's my step 1, step 2, step 3 that I keep yelling at you guys about. Oh, who knew? Okay, to add or subtract fractions, we must find a common denominator. And then the common denominator requires one of each term in the denominator. So one of each of those factors that I see, okay? All right, then we're going to multiply the numerator and denominator of each term by the missing factors from the common denominator. And then when subtracting, and I said this a couple times as well, so hopefully this makes sense, but just when subtracting, be extra careful of distributing that negative sign, okay? So that was an example, like if I had, x times x minus 2, I'm just saying, just be careful that you remember that's kind of like a negative x times x and a negative x times a negative 2, okay? There'd be something down here. I don't really care what it is right now. I'm just trying to say, hey, that'll end up being negative x squared plus 2x over whatever was down there, okay? Awesome possum. Okay, you cooked it. We can totally do this. Okay. Now you have a lot of practice. Okay, you have a lot of stuff for homework here. This is a lengthy piece, a lengthy chunk. But remember, I warned you of that at the beginning, and it's because we really want you to have the time to feel good about this. The way you feel good is to practice. Okay, you guys got this. Now, make sure you ask me questions. If you are not understanding anything, connect with me. I would love to help you out. And thanks for watching. I appreciate it. I really do. I appreciate taking this journey with you. I'm so grateful that you guys are telling your friends about these videos as well and that they're getting the help with these videos. That's really awesome. So thanks for doing that. And as always, thanks for subscribing to my YouTube channel. I really do appreciate it. And I really do appreciate you guys. You got this. Now go do some homework. Take care, guys.